Okay, so we are talking about dividing like bases now. We're on page 95 for honors, but for regular, we are on page 89. Okay, so let's talk about whenever we multiplied our like bases. That was over here. We figured out that the rule is when you multiply like bases, you add your exponents. So now we're going to look at when we divide them. So let's just think about dividing first. So 16 divided by 8. What does that equal? 2. Easy. Okay, but let's think about this in terms of 2 as our base. How can we rewrite 16 over 8 in powers of 2? I like how that looks. It's hard to read. How can we write 16 as a 2 to the power of something? 8 to the power of 2. 2 to the power of 4? Because that'd be 2 times 2 times 2 times 2, which is, 2 to the 4 is 16. Okay, what about 8? What would 8 be with the power of 2 to the third? Because I didn't do base of 4, because look how this came out to equal 2. So I wanted to think back on it being bases of 2. And that's a 3. It looks kind of bad. Okay. So whenever we have this actually looks like, if we expand it out, 2 times 2 times 2 times 2 over 2 times 2 times 2. And we could actually write these out where it's just one number over another number, like 2 over 2 times 2 over 2 times 2 over 2 times 2 over 1, right? But let's think about 2 divided by 2. What does that actually simplify to equal? 1. So I'm going to put a 1 over the top of it. With a different color. And we can't think about these as canceling. That's not the word we would use. We would use more like simplifying to equal 1. Because they don't cancel. They don't go to 0. They simplify to equal 1. So whenever they simplify to equal 1, the only thing we have left is 2 times 1, or 2 divided by 1, which is 2. But let's think about it to a power. What is the power if it's just 2? The first power. Remember on, I think it was Friday, we talked about the b's. B to the power of 0, b to the power of 1, b to the power of 2. If you have something to the power of, let's go down to the bottom, b2 would be b times b. But if you have b1, that's b. But then b0. If you have 0 b's, you don't have 0, you have whatever's being multiplied by that. What is being multiplied by each one of these? Now, we don't actually write, but everybody knows it's there. It's like our hidden multiple. What is it?
1.
1. So it's 1 times that, 1 times that, and 1 times that. So b to the 0 would equal just 1. So this has to be 2 to the first power, not 2 to the 0. A lot of people get that confused. Okay, so what rule could we use? What do you see about this relationship, 2 to the 4th over 2 to the 3rd being equal to 2 to the 1st? Do you see a relationship there with our exponents? 4, 3, and then 1. I wonder if there's a relationship with those exponents. Okay, let's go on. Let's do 64 divided by 8. What is that equivalent to? I could say 8. Yeah, it just equals 8. Let's think about this in terms of 2 being our base. How could I rewrite 64 and 8 as bases of 2? We know 8 because we wrote it up here, 2 to the 3rd. But what about 64? How could we double check it? I think it's 2 to the 6, so we'll double check it. 64, yep. So 2 to the 6. Okay, so let's do the same thing that we did up here. Let's expand it out. So 6 2s over 3 2s. Which we could match up numerator and denominator that are the same, put them over each other. With me? So then if I have 2 divided by 2, what does that equal?
1.
So let's write a 1 over the top. And then what do I have left? 2 times 2 times 2. What is that?
8.
8. But how can I write 2 times 2 times 2 simpler?
4 times 2.
2 to the power of 3. Which we know that is 8. Isn't this equal? 64 over 8 equals 8, which is 2 to the 3rd. So we transform this 64 over 8 to having bases of 2, and then we're able to simplify to get 2 to the 3rd, which still equals 8. So 2 to the 6 over 2 to the 3. Two to the 6 over 2 to the 3. That's what this is. What did we end up getting? 8, but let's write it as a base of 2 with the exponent. What did it equal? 2 to the 3rd. Do you see a relationship between those two? What relationship are you seeing? 3 times 2 to get 6. What about this one? You multiply 1 times, like, what do you notice about that? These two. Subtraction. What's 4 minus 3?
1.
Okay, so let's write that. 4 minus 3 equals 1. And then this one, 6 minus 3 equals 3. Okay. Was that following a pattern that you thought? I think somebody made a prediction. So that's good. All right, let's do 5 to the 5th over 5 to the 3rd. Let's expand it out just to make sure that we're still seeing the same result. So we'll do 5 times 5 times 5 times 5 and times 5. Over 5 times itself 3 times. And I'm going to skip this step, and I'm just going to write the ones right here. So 5 over 5 gives us 1. 5 over 5 gives us 1. 5 over 5 gives us 1. So that leaves me with 5 times 5, which we need to write that in terms of base of 5. 5 times, how many 5s are there? 2. So what we found was 5 to the 5th times 5 to the 3rd. Divided by. What did I just do? Don't write that. Over 5 to the 3rd equals 5 squared. So did that follow what we said earlier?
Yes.
Yeah. 5 minus 3 equals 2. Okay, so let's generalize it now.
You did 5 times 3.
5 minus 3. Sorry. My minuses. Like multiply. Yeah, 5 minus 3 equals 2. Okay, what about if we have 2 to the A over 2 to the B? Then following this same thing, let's write it as, what's our base? 2, and then our exponent? A minus B. What about if I have M to the A over M to the B? M to the A minus B, because I don't do anything with the base. I keep my same base. I just take my exponents and I subtract them. I find the difference between my exponents. So A minus B. Okay, let's do 3 to the 3rd times 5 over 3 squared. So what I need to do is expand them out, or could I just subtract those? Can I do anything with this 5?
No.
No. So, but I can still subtract these. 3 minus 2 times 5. So I subtracted the 3 and the 2. So whenever I do that, 3 minus 2 is 1. So 3 to the 1st power times 5. So let's go ahead and multiply that out. What does that get? Yeah, 15. Okay, the last one. 2 to the third times 3 to the second over 6. This doesn't look like I can do anything with.
Nope.
There's some way that we can simplify. There has to be. I can't really rewrite this. But what about 6? Can I rewrite 6 as a product?
2 to the third.
As a product, meaning two numbers being multiplied together. What would that be? 2 times 3. So let's write it as 2 to the third times 3 to the second over 2 times 3. Now, can I simplify those?
Yes.
What's going to happen here?
4.
What do I do with my exponents? But I'm dividing here. I can't do anything up top, but yeah, subtract. If you need to go back to doing this, you can. And I'm separating them so I can see how many pairs I have that I can simplify to equal 1. So then this is 1. And this is 1. So that's now 2 times 2, which is 2 squared, times 3. So all that happened here is that it's no longer 2 to the third. We took 1 away because there was a matching pair that equaled 1. So it's now 2 squared. 3 squared over 3. You take 1 away because it equals 1. That's just 3. Okay, so conclusion. We need a conclusion here. Since this is dividing like basis part 1, we're going to say when dividing like basis, what is the conclusion? Subtract what? Exponents. Do something around it so that it's hard to miss. All right, get out your worksheet from Friday where we did linear, exponential, or neither. Did y'all turn it in? Go ahead and get it out.